module, you're going to learn about percentage change. Let's look at what is percentage change. Now, percentage change is used in almost every aspect of life to describe change, and our world is always changing. For example, there are a number of examples here. Let's look at a few. If we are talking about the prices in the market always increase. For example, last year the price of onions increased. To explain it, people use terms like onion prices increased by 20% than what they were before. So they were comparing this to the previous price of the onions. Investments, profits, these are marketing terms where, if you remember, when we started fractions, decimals, and percentages, we were talking about a case study on Facebook where the person uses percentages to explain the profit and the investment the company is making. Attendance. If I have to compare your last year's attendance and this year's attendance, I would say your attendance increased or your attendance decreased. There is a percentage change in your attendance compared to last year. Growth, budgets, business, decay, especially in science, sports, when they are talking about runs or a performance of a player. So these are a few examples of how percentage change looks like in the real life. Taxes is one good example again. I think you can actually look at newspapers whenever the government budget is announced. They always try to explain the budgets in the form of percentages. Now, in this module, you're going to focus on these three things. You'll first find You'll first learn how to find percentage change when the original and the final value is given. Then you'll learn how to find final value when original value and percentage change, and so on. Now, if you saw the previous examples, in every example there are always two things. Whenever change happens, there are two things. One is in the past and one is in the future. I think as humans, when we change, also we describe ourselves like that, right? So when we are talking about monetary change or change in quantity, there is always a original value, which is the past value, and a new value or a new amount, which occurs after the change. This change can be positive and this change can be negative, just like it happens in our life. Now, expectations in this module. You're going to always make a flow chart which looks like this. Never forget to make a flow chart when you're solving a problem. Flowcharts help you understand the problem at great ease and lets you know what you have to find and what values are actually given. While explaining, when I pause the while explaining, when I pause and ask you to make a flow chart, please pause the video and you do so. Now, why don't we look at a quick question and then I'll talk more about it.
A person's salary was reduced by 20%. What percentage should be added to get back his original salary? The salary was reduced by 20%.
Now, think about this. Think about how a person's salary is reduced by 20%. Now he wants to get back the same salary. So, for example, I was earning 100 rupees and it reduced, and my salary became 80 rupees. Now, if I want to go back to 100 rupees, how much should it increase? Take a minute to answer this. Not 1 minute. Take 10 seconds to quickly think about what you would do. You can pause the video if you want. Now,
What percent should be added to get back his original salary? Simple. There was a 20% reduction, so we need to add back 20% to get back his original.
how many of you got this answer? I think there will be at least a few kids in every class who might have guessed this particular answer, right? But the thing
salary.
is,
As you would have guessed, it's not that easy. This is incorrect.
I'm sorry, this is not the logic. If there is a 20% decrease, you can't go back to the same amount by 20% increase.
Take a random number, say 100. As the problem says, let's reduce it by 20%. Reducing 100 by 20% gives us 80. Remember, reduction of 20% means 80% of original. Now let's try increasing this 80 by 20%. Increase of 20% means 1.2 times this. So 1.2 times 80 will be the result. And that equals 96, which is not the original number. Okay, we know it's not 20%. So what is the answer? We know that 100, when reduced by 20%, gives us 80. The question is, 80 has to be increased by what percent to get back 100?
So if you see here, this person is actually using percentage change to solve this particular problem. She took 100 and she used, there is a 20% decrease, which gave the answer as 80. Now, what is missing here? The original value is there, final value is there. Now she has to find the percentage change.
To avoid confusion, just look at this in isolation. The change is 20, 100 minus 80 is 20, and the original number is 80. So the percentage change will be 20 over 80.
So this is how you're going to find. So after she solves this particular problem, I think the answer will be 25%. So in case it's okay if you don't understand the whole calculations, by the end of this particular module, if you revisit this particular video, you'll be able to understand what all calculations she did. The takeaway from this video should be that if amount is decreased by 20%, adding 20% to the amount won't give the previous amount. Go ahead and solve the problems, girls. There is an assignment at the end of this particular module. Make sure you're submitting the assignment. Thank you.